Hello, my name is Plamen Dragiev, Senior Product Manager in Networking and Security Business Unit. In the next couple of minutes, I'm going to talk about one of our new features that will allow you to use stateful services on top of your Tier 0 or Tier 1 running in active HA mode. Let's get it started. VMware NSX 4.0.1 will allow you to use the services you're seeing on screen together with Tier 0 or Tier 1 gateway, which is configured in active HA mode. You'll be able to use next generation firewall, layer 4 firewall, URL filtering, TLS inspection, or NAT services at the time your Tier 0 or Tier 1 is configured in active HA mode. That will enable you to use the full power of your edge cluster and forward traffic through all your edge nodes in the edge cluster. Now let's take a look in a bit more technical details how that is happening. Stateful active edge scale out will enhance the existing concept of using an edge cluster with introducing an edge subcluster. That is a new concept that will come together with stateful active. You do not need to take any additional configuration steps for defining and configuring your edge subcluster. Important element into the edge subcluster is that each two edges of your edge cluster will form an edge subcluster. Edge subcluster is key element into the traffic forwarding and how stateful services are executed on top of your edge cluster. Now let's see why edge subcluster is important for traffic forwarding and for stateful active edge scale out. On the picture, we are seeing the same edge cluster we've been talking about in the previous slide with a bit more technical details. We are seeing our edge node 1 and 2, which is in the subcluster, and we are seeing our edge node 3 and 4, which are in another subcluster. Important component of the edge subcluster is that syncing element which is between the edges. It will take care about syncing all the flows which are between the edge node 1 and 2 or the edges which are paired in the subcluster. On the diagram, we are also seeing another new terms which are introduced in stateful active. It is a backup interface and shadow interface. You do not need to take any additional configuration steps to define those backup and shadow interfaces. Important element of the configuration and definition of stateful active is when you're creating your uplinks or service interfaces, you need to place your uplinks and service interfaces in the interface group. Now let's take a look how the traffic will be forwarded at the time we are having our application which needs to send traffic outside of our virtual networking infrastructure. On that slide, we are seeing our application which is deployed in our vSphere cluster, which needs to send traffic outside of our virtual networking infrastructure. And we are having our source IP address A, which needs to send the traffic to destination IP address B, which is outside of our virtual networking infrastructure. In that case, traffic needs to be forwarded throughout our edge cluster. We are seeing that ESXi is taking decision based on its hashing algorithm to send the traffic to our edge node 1. The important element of stateful active is that edge node 1 will take decision based on the destination IP address, which is the desired edge where the stateful services will be executed. In that specific case, we are seeing that edge node 3 is the desired edge where the stateful services, or in that specific case, NAT services will be executed. Then the NAT services will be executed on edge node 3 and we will forward the traffic north side to our top of the rack router. Now let's take a look how the traffic will be forwarded in the reverse path, or when our source IP address B in that case needs to forward traffic to destination IP address A or to our virtual machines which are living in our vSphere cluster. we are seeing that our top-of-the-rack router, based on its hashing algorithm, is deciding which is the edge node where the traffic needs to be forwarded. And in that specific case, we are seeing that our top-of-the-rack router is forwarding packets to our edge node 2. Then, based on the source IP address, edge node 2 is deciding which is the desired edge where stateful services needs to be executed, and that is an edge node 3. And it is pumping the traffic from edge node 2 to edge node 3, where the stateful services, or in that specific case, our NAT services, will be executed. And then we are forwarding the traffic down to our virtual machine. Important element which we need to keep in mind that in case of failure of our edge node 3, edge node 4 will take over the traffic and will continue seamlessly forwarding traffic and continue servicing the NAT services which edge node 3 has been executing. When we are talking about configuration and what we need to consider at the time we are designing and architecturing our stateful active-active topology is represented on that slide. We need to keep in mind that we cannot simply convert what we are having today as a stateless or as a stateful topology directly to stateful active-active. We need to pass through some configuration steps to reach to that point. It is important to remember that at the time we are doing our design and architecture for our stateful active-active topology, we need to have an even number of edges in our edge cluster. Another important element which we need to remember is tier 0 and tier 1 needs to be collocated on the same edge cluster, and that is during our configuration phase. Now let's take a look how we can deploy our stateful active-active topology in the greenfield deployment. That is pretty much straightforward scenario at which we are creating our edge cluster, we are deploying later our tier 0 and tier 1, we are configuring stateful active-active HA mode, we are putting our uplink interfaces and service interfaces in the interface groups, and then we can start consuming our stateful services on top of our topology. When we are talking about a brownfield deployment on when we want to convert what we are having today as a topology running stateful or stateless active-active topology, we need to consider those important elements. We cannot simply convert what we are having today. We need to do some configuration steps. One of the ways which we are supporting to convert directly from what we are having today as a topology, it is having a tier 0 running as in stateless, running as a stateless gateway, and not having connected anything to it, or not having any tier 1 connected to the tier 0 running in stateless active-active HA mode. Talking about the topology and what is supported and what is not supported, on that slide we are representing two of the supported topologies. Right side of the screen we are seeing most probably one of the most frequently seen topology, where we are running our tier 0 and tier 1 in active-active HA mode, and when we are consuming our stateful services on top of the tier 0 and tier 1. Right side of the screen we are seeing that specific topology which I mentioned that we may support it, at which we are having our tier 0 running in active-active HA mode and running a stateful services on top of it, at the same time having a separated edge cluster which is running as load balancer services on top of the tier 1. Another supported topology which you're seeing right side of your screen is having our stateful active-active tier 0 running on edge cluster 1 and having our tier 1 running in a DR only scenario. Left side of the screen we are seeing one of the not supported topology when we are having our tier 0 and tier 1 running on the separated edge cluster, and our tier 0 is running in active standby mode. That is not supported topology, you cannot use it, and it's not making much sense at the end trying to forward the traffic through a single edge which is on the tier 0. Last but not least, two of the not supported topology which we need to remember when we are using our tier 0 and tier 1 on the separated edge cluster, having stateful services on top of our tier 0 or having a stateful services on top of our tier 1, which we are seeing left and right side of our diagrams. That will be not supported topology, and you cannot use it in a stateful active-active gateway. With saying that, I would like to thank you very much and see you soon.